Good morning, student. Today I am going to discuss on a very simple theory of physical organic chemistry, that is thermodynamic and kinetic controlled reactions. You have done large number of experiments in your practical classes, and you have seen that sometimes the complete reaction is based on, or you are able to measure the rate of the reaction as per the stability of the product, and sometimes the rate of the reaction is governed by the rate of formation of the product. So this is a very important concept. So today I will discuss this thermodynamic and kinetic control reaction, and in this class I will only discuss only one particular reaction. So there appear large number of good research papers are also available regarding the thermodynamic and kinetic control reactions in different types of catalysis reactions. But here I will use some of the very simple type of the reactions. And if you want to learn much about this thermodynamically and kinetically controlled reaction, you can go through this type of the literature. Similarly, some of the proton transfer reaction also there is thermodynamic and kinetic control. But you can refer any undergraduate or postgraduate level organic chemistry book like Solomon's and Jerry Marks. You will get all this simple information. And there is one of the important aspects is that when you study the addition reaction of 1,3-butadiene and HBr, we observed that if the temperature is very low, there is a formation of 1,2 product is more than 80%, and 1,4 product is only 20%. But when we increase the temperature, we found that in that particular case that 1,2 product is less, but 1,4 product is high. So that means there is a switchover between the kinetic control and thermodynamic control of the reaction. So if you want to learn about this switching point between kinetic and thermodynamic control, you can also go through this paper. Now, actually, as I just told you in my introduction part, that if we are talking about the stability of the product, of course that is actually thermodynamics. And if we are concerned about the rate of product formation, then of course it may be related to the kinetics. Now, most of the cases, if the reaction is reversible, the most stable product predominates. And on the contrary, if the reaction is irreversible, the most rapidly formed product is predominant. That means that time, if the rate of the reaction is reversible, the rate of reaction can be controlled by the stability of the product. Whereas, if the reaction is irreversible, that can be controlled with the help of the product formation, which product is formed first. Now, this is a very common reaction, and you will get simple reaction in most of the books. So for the sake of student, I am also using this very common reaction for or to understand the thermodynamic control and kinetic control reaction, that is electrophilic addition of hydrobromic acid with the 1,3-butadiene. It's a very popular reaction, and I'll explain that which part is thermodynamic control and which part is kinetic control. But just bear in mind that suppose this is our main reactants, that is 1,3-butadiene. This is 1,3-butadiene, react with HBr. So there are two products, one is 1,2 product, another is the 1,4 product. So it is called electrophilic addition of 1,3-butadiene. So now I will explain this electrophilic addition reaction of 1,3-butadiene and HBr reactions, and then you can understand the actual process. I will explain this graph later on. Let me first explain the. Now see very carefully. So I am writing first here so this is 1,3-butadiene. Okay. Now react with HBr. Now, what is important? Important is that first, suppose temperature is minus 80 degrees centigrade. Suppose I am performing this experiment, very low temperature. So I am getting two products. First is CH3, CH, 1,2 products means CH3, CHBr. CH2. That is called 1,2 products. And second, and I just CH3, CH, CH, CH2, Br. You know that is 1,4 product, 1,4 addition. But the condition is that there are two products, but here it is 80% is predominant. 1,2 product is 80%, and 1,4 product is only 20%. Now the second condition, we increase the temperature around 40 degrees centigrade and we add some peroxide. Reactant is same, that is also same, product is also same, but here we will get again one-two product. It is 1-2 product, but you will be surprised to know that if we increase the temperature, the stability is only 20%. Whereas the other product like CH3, CH, CH, CH2Br is 1,4 product is just opposite, 80%. So you just see that reactant is same, but when you change the condition, here we are getting at low temperature the predominant product is 80%, 1,2 product, and 1,4 product is only 20%. But when you change the temperature, the 1,2 product is only 20%, whereas it is 80%. What does it mean? That means there is an equilibrium. That means if I write here CH3, CH, CH, I am talking about the high temperature. So it is a reversible case. It is of course 20%. So it is converted into it is 1,2 product. It is 1,4 product, we can write that. 3 CH, CH, and CH2Br. So one, which is more stable, that is a reversible process. Now, how do we explain that it is which part is thermodynamically controlled and which part is the kinetic control? Now I will explain the things. If it is a very low temperature where the rate of the reaction based on the formation of the product, where this product is predominant, this is actually, I can call it, but I will explain these things. It is kinetic control reaction, which is of course irreversible of nature. I will explain. And this high temperature, it is called when it depends upon the stability of the product, which is much stable. It is called the thermodynamic stable. Now, let me explain with the help of free energy of activation why it is kinetic control and why it is thermodynamic control, and why at very low temperature the formation of 1,4 product is very less, whereas the formation of 1,2 product is predominant. The reason is that. And if I just want to write the mechanism of this reaction, and it is a very simple reaction, so you can understand there is a formation of allylic cation. What is that? That means you know that first when we have taken the butadiene, so it will, there is a delocalization, so there is a, this H is, if I write like that, there is a CH, CH, CH2, so because first it forms H plus and bromide negative. So it will just react with this, and there is a partial positive charge and partial positive charge. It is called the allylic cation. So this first is hydrogen is here, so it will form Undo, where is undo? So when this hydrogen is reactive, so we can write this H3. And then of course that Br is gradually coming into picture and it will form that reaction. Now, before giving any explanation, I must know, because there is only one reactant, but there are two products, B and C. So in order to explain the thermodynamic control and kinetic control, we must know that what is the free energy of activation. Free energy of activation of one, suppose this is 1,4 product, and free energy of activation of 1,2 product. So now I'll explain what is the actual reason for that. It was observed that the free energy of activation from this allylic cation to the 1,4 product, the values of free energy of activation is high. So at low temperature it is very difficult for the molecules for the collision, so they are unable to cross that energy barrier. So therefore that A4 product is very less. Whereas at very low temperature, because the free energy of activation of this delta G of 1,2 product is relatively low, so there is a proper collision and they are able to activate. So that is the rate of reaction based upon this free energy of activation, and it is depends upon the formation of these two product formation. So therefore it is kinetic control. And in normal, when the temperature is very high temperature, so there is no problem of the collision, so then I can call it is a thermodynamic control. So now you can explain with the help of this simple free energy plot. So now you can understand these things. Suppose this is actually free energy part of this 1,4 product. So this is our intermediate allylic cation, you see, 1,3-butadiene. So there are two products. One is 1,4 product. You can call it is a 1,4 product. This is 1 and this 4. See this height, free energy of activation. Whereas if you see the 1,2 product, this is 1, this is 2. This is 1,2 product, relatively less. You can call it. This is not important. Important thing is the free energy of activation. So if the temperature is suppose very low, temperature is very low. So what happened? Molecule has to done much work to cross that barrier, which is very difficult at low temperature because there is less kinetic energy, less number of collisions. So it will be very difficult for that intermediate to cross that product. Whereas here he has to climb less. So but that can easily, so that 1,4 product and 1,2 product is irreversible because it is very difficult to just convert 1,4 to 1,2. So this is an irreversible process. And deciding factor is deciding factor is the rate of formation of 1,2 product and 1,4 product, and it is a irreversible nature. But at normal temperature, you know that when the temperature is very high, so that delta G is immaterial. So that can easily be, it can converted into 1,4 product and 1,2 product. So that is a reversible process, and that is called the thermodynamic control. Thermodynamic control reaction. So in a summary, there are large number of other examples are also available, but this is the simplest example for the student. You take the 1,3-butadiene is a electrophilic addition reactions, and there are two products, 1,4 product and 1,2 product. At very low temperature, 1,2 product is predominant. Rate can be controlled with the help of the rate of formation of the product. 1,2 product is formed first, so that we can monitor that reaction. When you increase the temperature, the products are same, but 1,2 product is less, 1,4 product will be high. So that is called the thermodynamic control reaction. Thank you.